Alright, in this video, I will be showing you guys how to do non-rotational solid problems, um, just calculus related problems. I figured that I'd make a video on it because either I'm not good at looking up things, but I didn't really find many videos on this subject, and also I want to understand this content better, so I might as well also show you guys and teach you how to do it. So let's first start with this problem over here. Um, Before I get into it, I just want to say the difference between non-rotational solids and rotational solids. Um, I'm assuming if you're watching this video, you were probably already you probably have a good grasp on like calculus 2, and you probably have a grasp of just rotational solids, disk, washer, shell method kind of thing. Um, with non rotational solids, instead of its volume being kind of, well, computed by its rotation in the 2D plane, like the XY coordinate, um, a non rotational solid has its volume accumulated by multiple cross section areas just stacked on top of each other and going between bounds. Um, that's as far as I understand it. Um, Let me know if I didn't say the correct term in the comments if you want to leave a comment. But that's how I grasp what non-rotational versus rotational solids are in the context of calculus. All right, so let's go ahead and solve this problem. The base of a solid S is a circular disk with a radius 8r. All right, so first let's make a xy coordinate plane and draw a circle. And it says that the radius is 8r, meaning that from the origin to the positive x direction, that will be 8r right here, this point. This point right here will then be negative 8r, since that's going in a negative x direction. And then the positive y direction will be 8r, negative y direction will be negative 8r. Just to put that there, because we're dealing with the circle. Parallel cross sections perpendicular to the base, so this is the base circle, are isosceles triangles with a height 4h and unequal in the base. Okay, so what's being stacked are these isosceles triangles, just like constantly. They're stacking up, stacking up, stacking up like that. And there's no rotation going on here, all right? So, and it says that it has a height, change the color, has a height of 4h. And my Mac battery is low. I should probably finish this very soon. Okay, so it has a height of 4h. So, first of all, let's find out what we need to know. We need to know what the area of a triangle is, right? So, if we remember from middle school, the area of a triangle is 1/2 base times height. We are already given the height. The height is equal to 4h, right? So you might be wondering, what is the base? Well, let's take a look at this triangle that I drew right here. If you notice, of course, this is not drawn scale, of course, but if you notice that in the first and fourth quadrant, there is the base of the triangle that extends on to both of these quadrants. So there's one right here, and we can designate that as y, right? By the way, you could technically also make cross-sectional triangles like in the direction that goes from positive y to negative y. But for simplicity's sakes, and just personally how I want to solve the problem, I drew my cross-sectional triangles on going just like between the negative x and the positive x direction. So anyways, so we have y right here, and we have another y right here, right? These two y's. That makes up our base. And what is y plus y? Well, that would mean that our base right here, so we can put that in red, base, that is going to be 2y. So we can rewrite this area just in general, right? So of this triangle, we can rewrite it. So area of triangle equals 1/2 2y 4h. And when you simplify that out, that will end up being 4hy, because 4h times 2y is 8hy. 8hy divided by 2 is 4hy. So that's how I came to that. You might be wondering, well, what do we do from here now? We just have 4hy as the area of this. Well, remember, we want to take the integral of this so that we can find the volume of it, right? That's, how we find just an area or volume of anything. We have to take the integral, but how do we take the integral of whatever we have? Well, we have to put this area into a cross-sectional function of sorts. So how do we do that? Well, let's solve for y right here. And how do we solve for y? Well, we're dealing with a circular base. And when graphed on a coordinate plane, we can actually graph that out in an equation, which is x squared plus y squared equals r squared. We already given the radius, right? The radius earlier was 8r. So we can just rewrite that as x squared plus y squared equals 8r squared. Okay. Now we're just gonna solve for y. So y squared equals 8r squared minus x squared. If we want to get rid of the power of 2 on this y, you want to take the square root. So 8r squared minus x squared. If you notice anything, well, we solved for y. This y right here, which equals to this y can now be replaced with this. So we're going to rewrite this equation now, and we have finally found our cross-sectional function, right? This is going to be a function, this area, which we will call a of x. So a of x is going to equal 4 to the square root of 8r squared minus x squared. That is our cross-sectional area function. Now, we want to put this into an integral, right? So that we can find the area or the volume of this entire thing, because we're splitting it into so many different cross-sectional points between certain bounds, right? So the formula for finding a non-rotational volume solid will be this. Volume equals, from the bounds of a to b, a of x dx. Okay? So we already have a of x. You might be wondering, what is our bounds? Well, remember, we're dealing with a circular base, and it has a radius of 8r. Remember how I said that in the negative x direction, the last point is going to be negative 8r, and in the positive x direction, that last endpoint is going to be 8r? Well, those are like, the bounds of the circle itself, and we want to get the volume of the circle, so we're going to measure by the bounds of when the circle base starts and ends, which is going to be negative 8r and 8r. Those are going to be our bounds. So volume is going to equal to negative 8r to 8r. Oh, I forgot the 4h over here. My bad. Sorry. 4h square root of 8r squared minus x squared. Okay. So this is our integral. we have set up our integral. Actually, no, we have not finished yet because this integral is pretty difficult, right? It's just difficult to handle. If we know anything about circles, and if you know some geometry, you know that you can use the power of just geometry, I guess, that you know from middle school, high school, and you can split this circle in half. And then when you split this circle in half, then just times it by 2 again so that you can get the area of the other side. That will make this a lot easier to handle. Let me show you. So then volume is going to equal to 2. So we put 2 out here, and we make our bounds from 0 to 8r, which means that now our bounds are from here to here. Oh, highlight in red. Cool. 0 to 8r, 4h square root of 8r squared minus x squared. Okay. Which then we can just bring this out. V equals 8h to 0 to 8r square root of 8r squared minus x squared. All right. Now, you might think this looks still a bit more difficult, but we can use geometry again to just honestly just find this area. And we don't even really have to integrate anything or use any integration rules for this because we know a lot about geometry. This expression itself, all this really is just the quarter of a circle. Remember, this whole expression is just a quarter of a circle because our bounds are from 0 to 8r, and we're dealing with just this part right here, right? If I wanted to graph this, look like this, right? You just find the area of this. So how do you find the area of this? Well, how do you find the fourth of a circle? That formula is going to be 1/4 pi r squared. We know our radius, it's 8r. It's 8r squared. That's our radius. So we can just put in 1/4 pi 8r squared squared. Just checking to make sure. Yeah, there you go. We can just put it like that. At the end of the day, from this, so 8 times 8, 64. So you get 64r squared, or well, 64r squared pi over 4. 64 divided by 4 is 16. So this integral right here, actually, let me turn this red. This integral, ignoring the constant, this is going to end up being 16 pi r squared, because this expression, once again, is the expression for just the quarter of this circle. We don't have to do any kind of integration rules or anything. We just know, just by geometry and just honestly just, ninth grade math, that we can just take the quarter of a circle area and find this. So this is 16 pi r squared. We're not done yet. I'm just going to draw an arrow right here because we have a constant, h. 16 pi r squared. Also, if you're wondering whatever happened with the 0, I mean, like, even if you plugged 0 into this entire equation, it would just make the whole thing 0, so that doesn't even matter. So then you do 8h times 16 pi r squared, and you end up getting 128 h pi r squared. And that is the volume of your non-rotational solid for this problem.